This oak tree analogy was created to introduce the concept of value-added calculations. It is not in the education context, in an attempt to keep this overview of the theory of value-added separate from details specific to its use in education. In this analogy, we will be explaining the concept of value-added by evaluating the performance of two gardeners. For the past year, these gardeners have been tending to their oak trees, trying to maximize the height of the trees. Each gardener used a variety of strategies to help their own tree grow. We want to evaluate which of these two gardeners was more successful with their strategies. To measure the performance of the gardeners, we will measure the height of the trees today, 1 year after they began tending to the trees. With a height of 61 inches for oak tree A and 72 inches for oak tree B, we find gardener B to be the better gardener. This method is analogous to using an achievement model to evaluate performance. But this achievement result does not tell the whole story. These gardeners did not start with acorns. The trees are 4 years old at this point in time. We need to find the starting height for each tree in order to more fairly evaluate each gardener's performance during the past year. Looking back at our yearly record, we can see that the trees were much shorter last year. We can compare the height of the trees 1 year ago to the height today. By finding the difference between these heights, we can determine how many inches the trees grew during the year of gardener's care. By using this method, gardener A's tree grew 14 inches, while gardener B's tree grew 20 inches. Oak B had more growth this year, so gardener B is the better gardener. This is analogous to using a simple growth model, also called gain. But this simple growth result does not tell the whole story either. Although we know how many inches the trees grew during this year, we do not yet know how much of this growth was due to the strategies used by the gardeners themselves. This is an apples to oranges comparison. If we really want to fairly evaluate the gardeners, we need to take into account other factors that influenced the growth of the trees. For our oak tree example, 3 environmental factors we will examine are rainfall, soil richness, and temperature. Based on the data for our trees, we can see what kind of external conditions our 2 trees experienced during the last year. Oak tree A was in a region with high rainfall, while oak tree B experienced low rainfall. Oak tree A had low soil richness, while oak tree B has high soil richness. Oak tree A had high temperature, while oak tree B had low temperature. We can use this information to calculate a predicted height for each tree today if it was being cared for by an average gardener in the area. We examine all oaks in the region to find an average height improvement for trees. We adjust this prediction for the effect of each tree's environmental conditions. We compare the actual height of the trees to their predicted heights to determine if the gardener's effect was above or below average. In order to find the impact of rainfall, soil richness, and temperature, we will plot the growth of each individual oak in the region compared to its environmental conditions. On the x-axis, we plot the relative amount of each environmental condition. On the y-axis, we plot how much each tree grew from year 3 to year 4. Each dot represents a single oak tree in the area. By calculating an average line through the data, we can determine a trend for each environmental factor. From the data we collected for our region, we find that more rainfall and higher soil richness contributed positively to growth. Higher temperatures contributed negatively to growth. Now that we have identified growth trends for each of these environmental factors, we need to convert them into a form usable for our predictions. We can summarize our trend information by determining a numerical adjustment based on high, medium, and low amount of each environmental condition. For example, based on our data, we found that oak trees that experienced low rainfall tended to have 5 fewer inches of growth compared to the average growth of oak trees in the region. Trees with medium rainfall tended to have 2 fewer inches of growth compared to the average. Trees with high rainfall tended to have 3 more inches of growth compared to the average. We calculate these numerical adjustments for all environmental conditions to summarize the trends from the data. Now we can go back to oak A and oak B to adjust for their growing conditions. To make our initial prediction, we used the average height improvement for all trees. Based on our data, the average improvement for oak trees in the region was 20 inches during the past year. We start with the tree's height at age 3 and add 20 inches for our initial prediction. Next, we will refine our prediction based on the growing conditions for each tree. When we are done, we will have an apples-to-apples comparison of the gardener's effect. Based on data for all oak trees in the region, we found that high rainfall resulted in 3 inches of extra growth on average. For having high rainfall, oak A's prediction is adjusted by +3 to compensate. Similarly, for having low rainfall, oak B's prediction is adjusted by -5 to compensate. We continue this process for our other environmental factors. For having poor soil, oak A's prediction is adjusted by -3. For having rich soil, oak B's prediction is adjusted by +2. For having high temperature, oak A's prediction is adjusted by -8. For having low temperature, oak B's prediction is adjusted by +5. Now that we have refined our predictions based on the effect of environmental conditions, our gardeners are on a level playing field. The predicted height for trees in oak A's conditions is 59 inches. The predicted height for trees in oak B's conditions is 74 inches. Finally, we compare the actual height of the trees to our predictions. Oak A's actual height of 61 inches is 2 inches more than we predicted. We attribute this above-average result to the effect of gardener A. Oak B's actual height of 72 inches is 2 inches less than we predicted. We attribute this below-average result to the effect of gardener B. Using this method, gardener A is a superior gardener. By accounting for last year's height and environmental conditions of the trees during this year, we have found the value each gardener added to the growth of the tree. This is analogous to a value-added measure. This analogy was purposefully kept out of the education context. How does this analogy relate to value-added estimates in the education context? What are we evaluating? In the oak tree analogy, we evaluated gardeners. In the education context, we are evaluating districts, schools, grades, classrooms, programs, and interventions. What are we using to measure success? In the oak tree analogy, we measure relative height improvement in inches. In the education context, we measure relative improvement on standardized test scores. What about our sample? In the oak tree analogy, we only used a single oak tree per gardener. In the education context, we use groups of students. What do we control for? In the oak tree analogy, we analyzed rainfall, soil richness, and temperature. We were then able to incorporate their influence in our prediction. We call this controlling for these factors. In the education context, we control for prior performance. This tends to be the most significant predictor of student performance. Based on what other data is available, we also control for other factors beyond the district, school, or classroom's influence, such as grade level, gender, race or ethnicity, low-income status, ELL status, IEP status, homelessness, and mobility.